In this question, we are going to show first of all V1 and V2 are subspace, and we're going to find what is V1 plus V2 and what is V1 plus V1 intersection V2. So I take two elements in W1. I want to show that W1 is a subspace, so I take two elements in W1. So the elements look like this, and I take two scalars in the field. So we have alpha of this plus beta of this. You multiply alpha to each, beta to this, then you add the two matrices. You know how to add two matrices, so we get this form. Now you check here, these are elements, x1 x2 are elements of the field. Okay, x1 x2 are elements of the field, as well as alpha and beta is the element of the field. So since alpha is an element of the field, x1 is an element of the field, so the product also will be an element of the field. Same way here also, so the sum of two elements of the field is again an element of the field. So this is again an element of the field. Similarly, this is also an element of the field, and this is also an element of the field, and here we get 0. So it is of this, the elements are of the type x, y, z, 0, which belongs to W1. So that shows that W1 is a subspace of F2 cross 2. Okay, so we have shown that, and now we are trying to show that W2 is a subspace. So I'll take two elements in W2. So the elements look like this, where alpha beta belongs to the field. So I use the linear combination, then I multiply alpha to each, beta to this, then we'll add by addition of two matrices, so we get this. Similar to what I have explained in the above, alpha is from the field, x1 is from the field, beta is from the field, x2 is also from the field. So the product of two elements of the field is again an element of the field, and also in the same way here. So these two are elements of the field. So if we add two elements of the field, it is again an element of the field. So this one will belong to the field, and this also belongs to the field. So it is of the form x0, 0, z. Okay, so that is of the type W2. So this belongs to W2. So W2 is a subspace of F2 cross 2. Now we'll try to compute what is W1 plus W2. Okay, so we are trying to compute what is W1 plus W2. So we take one element from W1 plus one element from W2, and these are all elements belonging to the field. Then we'll add these two matrices. We get x1 plus x2, y1, z1 plus z2 of this type. So we get this will be also belonging to the field. This is also belonging to the field. This is also belonging to the field, and this is also belonging to the field. So we get a 2 cross 2 matrix. That is the vector space itself. Okay, so we get the vector space that is F2 cross 2. So here W1 plus W2 is nothing but F2 cross 2. Now we'll try to find an element in W1 intersection W2. How does it look? So I take an element in W1, and if I take an element in W1 intersection W2, so this element will belong to W1 as well as this element will belong to W2. So I take an element here, it belongs to W1, and it also belongs to W2. So since an element belongs in W1, it can be written of this type. It is of this form. And here the element belongs to W2, so it is of this type. Okay, now if you look here, this is A, this is also A, so these two should be equal. So we get these two to be equal. So what we get here, x should be equal to x1, y should be equal to 0, z should be equal to 0, and z1 also should be 0. So if I put this value of y, z, and z1 in any of these, I'll get of this form. So we are left with only this. Okay, so the intersection consists of only this type of element. Okay, the intersection consists of only this type of element where x belongs to the field. Thank you.